Today we're going to do one sample problem. The sample problem is going to be a limiting reactant problem for the production of hydrogen peroxide, something pretty common you have in your own home. It's actually number 57 from your textbook, so we can just read it together. Hydrogen peroxide is used as a cleaning agent in treatment for cuts and abrasions for several reasons. One, it's an oxidizing agent. We're going to learn that idea later on. It can directly kill many microorganisms, and it decomposes upon contact with blood. It releases elemental oxygen gas, and oxygen gas inhibits the growth of anaerobic microorganisms. You'll learn that in extreme biology. And it foams upon contact with blood, which provides a cleansing action. In the laboratory, small quantities of hydrogen peroxide can be prepared by the action of an acid on an alkaline earth metal peroxide, such as barium peroxide. So here's the question. If 0.0015 kilograms of barium peroxide reacts with 25 milliliters of hydrochloric acid, the density of hydrochloric acid at this concentration is 0.0272 grams per milliliter to produce hydrogen peroxide and barium chloride. What amount or mass of hydrogen peroxide is produced? So this is basically the same limiting reactant problem we've done in the past. The only thing is, for each factor label, in the past we've had 3 steps. I'm going to add 1 step to each problem. One reason there's 1 step for the first one is we're starting with kilograms instead of grams. And the other one is we're starting with a volume for hydrochloric acid. So we're going to have to use the density of hydrochloric acid to change that to grams. And hopefully you guys remember the formula for density. Density equals mass divided by volume. Okay, so let's start the problem. The first step of doing the problem is to write a balanced equation. So if you go back to the question, it should be barium peroxide reacts with hydrochloric acid, and the products are hydrogen peroxide and barium chloride. You don't need to write states, but it'd be helpful if you'd balance that. So see if you can write the reaction. So if you wrote the reaction looks like this. And notice the amounts they give us are the kilograms that's of barium peroxide, so we're going to have to change that to grams. And then they give us the milliliters of hydrochloric acid, and we're going to have to use a formula for density to change that to grams as well, because we know density is equal to mass divided by volume. So mass is equal to density times volume, because we know density is in grams per milliliter. So we're going to use both those to do this problem. So this will help us figure out the amount of hydrogen or mass of hydrogen peroxide that's produced, which is a product right here. And this is, we'll also learn later how to draw molecules such as hydrogen peroxide like that. That's second semester. So if you wrote the balanced reaction, this is what it looks like. And this is hydrogen peroxide. And then this is a grams of barium peroxide, or the kilograms of barium peroxide, and milliliters of hydrochloric acid. So if you start the problem, first we have the balanced reaction. So you want to go from, we'll start with the barium peroxide, and we're going to change that to hydrogen peroxide. So the first step, I've already started out, is you want to change milliliters to grams. Now we do that, we know density, mass is equal to density times volume, so I took the volume, which is in milliliters, and multiplied by the density, which is in grams per milliliter. Notice milliliters cancel out. And then I want to change, and these are still, remember we said in the limiting reactant problems or gram-to-gram problems there's 3 steps. These are the 3 steps, step 1, step 2, step 3. I guess we could say we've added a step 0 because we don't have grams initially. We're going to change grams to change milligrams to, we're going to change milliliters to grams. So the first step we already did that, and now we're going to change grams to moles by using the molar mass. So this is, so this actually, this is step 1, so we're going to change grams to moles. So we see grams of hydrochloric acid cancels. So we still have to use a mole ratio from the balanced equation. We're going to have to change moles of our product to grams. So let's do that next. So we'll have the balanced equation here. We see the mole ratio from the balanced equation, which is 2 moles of hydrochloric acid produce 1 mole of hydrogen peroxide. So now we're able to do that. Then we use the molar mass of hydrogen peroxide, which is 34, to change moles of hydrogen peroxide to grams. So now we've gone from hydrochloric acid to hydrogen peroxide. Now we've got one more. Now we've only done one reactant. We actually have to do both reactants to see which will give us the smaller number and tell us what's limiting and what's excess. So to do this in our calculator, we'd say 25 times 0.0272 divided by 36.5 divided by 2 times 34. Enter. and that should give you 0.30 grams of hydrogen peroxide. Now, we don't know if this is limiting the excess reactant or that's the amount of product. We have to do two problems. So we've done from hydrochloric acid to hydrogen peroxide. Now we need to do from barium peroxide to hydrogen peroxide. So let's do that problem. So first we're going to start with the kilograms, and this is what I said is different. This is, maybe you call this step 0. We're going to have to change kilograms to grams. You have to remember how many milligrams in a gram, how many grams in a kilogram. There are 1,000 grams in a kilogram, and so that will allow us to cancel that. One thing I want to go ahead and apologize for, when I use this equation, when I write the equations, I'm not able to use subscripts for my substances, so I apologize that barium peroxide and hydrogen peroxide are written not as subscripts, or just written as total numbers, so I apologize for that. So now we've got grams of barium peroxide. We want to change that to moles, so this is really step 1. Then we have step 2, we're using mole ratio. In step 3, we change moles of unknown to grams. So those steps are exactly the same. So then I have grams of barium peroxide. I want to change that to moles. Now I need to use a mole ratio from the balanced equation. Now we see the mole ratio from the balanced equation is 1 to 1. So this is really going to be a 1 to 1. And then this will be a 1 over the molar mass. So your final step should just look like this, where you have 1 mole of barium peroxide over 1 mole of hydrogen peroxide. Once again, we see kilograms cancel, grams cancel, moles of barium peroxide cancel, and also moles of hydrogen peroxide cancel. Then we finally end up with grams of hydrogen peroxide. To get this answer, all you're going to have to do is say 0.0015 kilograms times 1,000 divided by 169, and then you don't need the 1 over 1, then just times 34 and you get your answer. When I do this in the calculator, this is the number I get, 0.32 grams of hydrogen peroxide. What does this actually mean? Well, there's 3 things we should be able to get from this. We should be able to get what is a limiting, what is the excess, limiting reactant, excess reactant, and how much product we produce. Hopefully you're familiar with all these enough at this point you can do that. So the limiting reactant for this should be, hopefully you picked HCl. So the limiting reactant is HCl, and then the excess reactant is the one that didn't run out. That would be barium peroxide. There would be barium peroxide left at the end of the reaction. The amount of hydrogen peroxide that we produced would be 0.30 grams. You do not produce 0.32 grams, and that's not used for anything else. It just tells us that that is excess, that's the excess reactant. So that's how you do this problem. If you have any questions, let me know. Have a great day.